Hi, Year 11. I hope you're all well and not going too crazy at home last week of term. We're going to do some work on surds this week, which is a slight deviation from the topic we recently started on construction, but construction isn't a topic that lends itself well to remote study. So we're going to come back to that in the new year, and this week do some work on surds, which I think is one of the really nice topics of what we've got left in higher tier GCSE. So put yourself a date and a title in whatever you're working in. Hopefully you've got your exercise book, but wherever you're working, put yourself a date and a title. Simplifying Surds 1 on the 14th of December. Now, there really is one key rule to surds. Surds is just a load of sort of manipulation we do with square roots. But the one key rule, really, and certainly the rule we're going to be focusing on today, is that the square root of A times the square root of B equals the square root of AB. Make sure if you've got your blue book with you, you make a note of that rule. And all it's saying, it's a very intuitive rule, is that the square root of one thing times the square root of another thing equals the square root of those two things times together. Now, this rule sometimes we use both ways. So sometimes we convert things in this form to something in this form, and other times we go in reverse, something from this form to this form. But today we're going to do the first of those two, focus on the first of those two. And here's some examples, which I would also put in my blue book, I would suggest, if you have it with you. So the square root of 7 times the square root of 5 is just going to be the same as the square root of 7 times 5. So it's the same as root 35. And that's all there is to sort of the most basic implementation of this rule. Let's have a look at this one. Square root of 12 times the square root of 3. Well, that's going to be the same as the square root of 12 times 3, which is the square root of 36. And now we're going to hit on another key point of surds, one of the main things we do with surds, which is finding, or whenever we do find, anything inside a square root that is itself square, then square rooting it. So the square root of 12 times the square root of 3 is the same as the square root of 36, which is just the same as saying 6. Don't want to just leave it as root 36 because I know root 36 is 6. And here's a similar one. Look, square root of 4 times the square root of 4 equals the square root of 16, which just equals 4. And actually, we already know that, don't we? If we've got the square root of something times the square root of that same thing, then it's going to give me that number. That's why it's called square root. We can also raise these surds to powers. Here's a very similar one to the one we just did. Square root of 6 squared means the square root of 6 times the square root of 6, which just gives me 6. I could write that it's root 36, but we know that the square root of something times itself gives you that thing. Slightly different one here. We've got the square root of 11 cubed. So that's going to be the same as saying root 11 times root 11 times root 11. Now I know that the square root of 11 times the square root of 11 equals 11. So I've just got 11 times this square root of 11, root 11. That should be enough to get you through questions 1, 2, and 3. There's sort of quite a few questions in there, but a lot of them are quite simple, just like these ones here. So spend about 10 minutes on 1, 2, 3. That should be enough, I would say, probably to finish 1, 2, and 3. But spend about 10 minutes on questions 1, 2, and 3, and then come back to the video. Okay, hopefully you've got through questions 1, 2, and 3, and you've marked those answers as you've gone. Those answers are on the next slide over. Now we're going to have a look at a slightly new one. Oh, let's make sure I get my right piece of paper. And we're going to look at multiplying surds where there are coefficients. So here's our two examples. I've got 4 root 3 times 10 root 10. Now really all we've got here are 4 things being times together, because 4 root 3, just like 4x means 4 times x, 4 root 3 means 4 times root 3. So I've just got 4 times root 3 times 10 times root 10. And just like with any multiplying, I can multiply in whichever order I want. So I can do 4 times root 3 times 10 times root 10, but I know that's the same as saying 4 times 10, which is 40, times root 3 times root 10, which is root 30. So it's as simple as that, really. I've just decided to multiply together the integers, multiply together the surds to give me an answer. Here's another one. I've got 2 times root 8 times 5 times root 2, which is just going to give me 10 for the 2 times 5. The root 8 times the root 2 is root 16. Have you spotted it though? What can you notice in there? We've got a square number inside a square root. Root 16 is 4, so it's just 10 times 4, which is going to be 40. All really key, I cancel it down. Just like cancelling down fractions, you cancel it down as much as you can. And when you spot that square root sign, you make sure you square root the thing inside it. Okay, that should be enough to get you through question 4. Again, there are 10 questions in question 4. I think you should be able to do those about a minute a question. Some of you do them quicker than that. So about 10 minutes on question 4, making sure you mark your answers on the next slide and then come back to the video. Okay, then the last thing we're going to look at today is dividing surds. And just as you might imagine, we know that root A times root B equals root AB. Well, the same thing applies with dividing. And there's a couple of different ways you could write it, but I would write it like this. I would say that square root of A over the square root of B equals the square root of A over B. You can see I've written it in fraction form there, but you could write it with a divide symbol as well. And again, just like with multiplying, sometimes we go from this one to this one, and sometimes we go from this form to this form. Today we're going to be mostly going this way. So here's 3 examples. Let's get my paper in order. Square root of 52 times the square root of 2 is just square root of 26. Simple as you like. Here's some with some coefficients. I can do just like the multiplying one. I've got this whole thing here divided by this whole thing here. 12 divided by 2 is 6. Root 30 divided by root 10 is root 3. And my last one here is written in fraction form. That means literally nothing. Still doing this divided by this. 4 divided by 2 is 2. Root 75 divided by root 3 is root 25. Have you spotted it? That's right, we've got a square number inside a square root. So we've got 2 times root 25, which is the same as 2 times 5, or just 10. So that should be able to get you through questions 6 and 7. Again, I don't think you should need much more than about 10 minutes or so on those questions. Don't spend more time than that, making sure they're 10 focus minutes, not 10 minutes doing a bit of work and then having a quick go on Instagram. Okay, so hopefully that will take you through about an hour, maybe slightly under for those of you bang on it today on surds, and we'll carry our work on that tomorrow. Have a great day, all the best with the work. Drop me an email if there are any problems, and I'll see you tomorrow.